Okay.
Okay, so the bell work, write the balanced chemical formula for methane in a combustion reaction. Everybody should remember what the reactants and products in a combustion reaction are, because they're always the same. What is methane reacting with in a combustion reaction? Somebody raise your hand. Connor? Oxygen. What are the two products in a combustion reaction that has a hydrocarbon as a reactant? Connor?
Water and carbon.
CO2 and H2o. So you're going to write CH4 plus O2 produces arrow CO2 plus H2O. Then you're going to balance. Then you're going to do the same thing for ethane, if you haven't found it. Then we'll put it on the board here for you. Sure. Okay, so here's your three reactions. All three of these combustion reactions with what we call a hydrocarbon in the reactant spot are going to form the same two products, CO2 and H2O. So your goal is to balance these. I'll talk about this in a second. Let me finish my attendance while you try and figure those out. If anybody wants to get a jump on signing up for your research paper, I've got the sign-up sheet available. I'll pass it around. Do not feel like you have to. And if I find that more than 3 people have signed up in any of these sections, you can look at the back and find 31 and 32. Okay? And 33 starts here. I won't allow more than 3 people to do the same research paper. Okay? So if you're the 4th person to sign up, then I'm going to either contact you today or Tuesday or Wednesday or Thursday or whatever and say you got to choose another. First come, first serve. Ben is still sick, maybe. Kinsey is, she's not at the drama thing, is she? Is she? Okay, because I lost my, somewhere on this table.
Debski's the 6th period.
Yes, 6th period. Oh, right, P6, right where I wrote P3. That's just to keep them separate. P3 is not there in research papers. Fisher, yes. Gaston, yes. Harris. Johnston's still sick. Kelly, were you here this morning? Yeah, you were here. Molly aces that test, then come to school. Overstreet, Reeves. Oh, poor Garrett, man. I'm gonna stop by his house today and see how he's doing. And Stagner, Sullivan's at, she at the
Yes, sir.
thingy?
Yes.
Okay. Good. So, who's got the coefficients for methane? Mr. McGarry.
1, 2, 1, 2.
Okay, 2 and 2. This one's pretty simple. Just double check. You got 4 oxygens here, 2 plus 2 oxygens over there, 4 hydrogens, 4 hydrogens, 1 carbon, 1 carbon. Cool. Second one, Gabby.
1, 5, 2, 3.
Okay. And again, I'm not going to take the time to do this out, but if you make a list, take your inventory, start balancing, do carbon first, do hydrogen second, and then you see you need 10 oxygens on the left-hand side. So what number times 2 gives me 10? 5. Good job. 1, 5, 2, 3. They get a little bit more difficult as we work down. Who's got the third one? Okay. So start with your CH and O, right? Just work them one at a time. 3 and 1. I got 8 and 2, and I got 2 and 3. So what's the coefficient for CO2 got to be? I got 3 carbons here and 1 carbon over there. Multiply by 3. That changes this number to 3, changes this number to 6 plus 1, 7. Second step, hydrogen. What's going in front of H2O? Got to put a 4 over here. Let's do that in green. 8 hydrogens now. And over here, 8 hydrogens already. 4 oxygens plus 6 oxygens. Now I'm up to 10 oxygens. Last step. Is that 5 too?
No, I don't think we're
It's
going
2, 7, 4, 6.
Usually have this thing.
Yeah. What did I do wrong? So I got 8 hydrogens.
I know which one.
4 oxygens is 6 is 10. What did I do wrong?
You put a file in front of O2 on the bottom. That's right. Which one do you know this is?
I'm doing the third one.
Okay, all you gotta do is put a file in front of O2.
Yeah, but
Then you have 10 and
this
10.
isn't the same as this. Is this one right?
No, that one's not right.
That's completely wrong. Gabby, what are you doing to me? Okay, let's redo the second one here. Okay? So I need 2 carbons over here. That's going to be 4 oxygens and 1. That's 5 oxygens. Okay, do the hydrogens next. I need to have a 3 here, right? 3 times 2 is 6. So that gives me 2 times 2 is 4, plus 3 is 7. 7 oxygens here and 2 here. So this is one where you go 3.5. Okay, 3.5 times 2 is 7, and then double them. So we end up with the following coefficients: 2, 7, 4, and 6. Does that make sense? 2 carbons, 2 times 2 is 4, I got 4. 2 times 6 is 12, 6 times 2 is 12. 7 times 2 is 14, 4 times 2 is 8, plus 6 is 14. Gotcha. I think you did this one. Okay? Balancing reactions. Practice, practice, practice. You're not going to get anywhere unless you do it. Yeah, just leave it there. Okay? Take your notes out. And that was the bell work today. We are talking about more stoichiometry. We left off here yesterday. Please take your homework out, pass that to the back. I will take a look at it over the weekend. It's pretty simple. Shouldn't have been terribly time consuming. I'm looking for words, moles, and mass. So pass that to the back. Chase, if you could collect those and drop them on the windowsill for me, that'd be awesome. Everybody else, we're going to start and continue in our notes today talking about mole ratios. Okay? Now this is a really simple definition because a mole ratio is a ratio of moles. How about that? Like the molar mass is a mass of mole. Okay? So a mole ratio is the ratio. Remember, just we can write ratios 2 different ways, either using a colon or using a fraction. If I say something has a 2 to 5 ratio, we can also write that as this, a 2 to 5 ratio. Okay, so ratios are simply a comparison of 2 numbers. So the mole ratio is a ratio between the numbers of moles of any 2 substances, only 2, in a balanced reaction. So if we balance this is one of the ones we just did. Cool, ties right into my bell work. Oh, I'm so proud. Okay, and so we would say if I want to burn 2 moles of ethane, I need to have 7 moles of oxygen. For every single atom to react, I would need this exact ratio, 7 of these to 2 of these. Because remember, on a microscopic level, what we talked about yesterday afternoon, with iron and oxygen, right? I need to have 4 atoms of iron to react with 3 moles of O2 to give me 2 of these Fe2O3s. So in order for every atom to react perfectly, nothing left over, I need 2 moles of ethane to react with 7 moles of oxygen. When I compare those 2 coefficients, it's called a mole ratio. I can write that like this: 2 moles of ethane per 7 moles of O2. I would say 2 moles of ethane burn every time 7 moles of oxygen react with it. Or I could flip it upside down and say 7 moles of oxygen are required to burn 2 moles of ethane, something like that. Now, there are a lot of different combinations in a single reaction. Let's look at a few of the options available. I could also say on this reaction, 2 moles of ethane will produce 4 moles of CO2. 4 to 2 ratio, 2 to 4 ratio. 4 moles of CO2 are produced every time 2 moles of ethane react. Am I following so far? We're just comparing the coefficients in a ratio. Another thing I could say, keep going, we will be exhaustive here. 2 moles of ethane react to produce 6 moles of water. Ta-da! And 6 moles of water are produced every time we burn 2 moles of ethane. All of these are true. But a ratio only compares 2 things. So I can pick any 2 things in this, and there's another combination here. 7 moles of oxygen are required to produce 4 moles of CO2. Get the hint here? And 4 moles of CO2 will be produced if I use up 7 moles of O2. Which combination haven't we done yet? 7 moles of oxygen will produce 6 moles of water, and 6 moles of water will be produced if I burn 7 moles of oxygen. Which one haven't we covered yet? 4 moles of carbon dioxide are produced every time 6 moles of water are produced. And 6 moles of water are produced every time 4 moles of CO2 are produced. We good? How many combinations do we have? A lot. There is actually a rule in math to calculate this. I don't remember what it was. It has something to do with permutations and combinations in probabilities. But it's this one, both ways. 2 of those, 2 of these, 2 of these. So that's 6, 8, 10. No, I missed one. 2, 4, 6, 8, 10, 12. There's 12 combinations we covered, okay? So 12 combinations for something that has 2 reactants and 2 products. It'll change. We will have a lot more combinations if we have 3 reactants and 3 products. Question number 1, because we're done section 1. How about that? Which of the following is a correct mole ratio for aluminum reacting with bromine, producing aluminum bromide? Three of these are blatantly wrong. Only one is true. Connor? B. Okay. Answer this question. Why is A wrong? Somebody raise your hand. Why is A wrong?
This is BR, not BR2.
It says BR, not BR2. So we can't change these things. Okay. This is 3 moles of BR2. Why is C wrong? Connor? Yeah, it says 1 mole of BR2 and the coefficient is 3. Why is D wrong? Reagan?
Because this is 2 moles of BR2. Or just because that would be actually.
There's 2 things wrong with it, right?
Yeah.
So it says
That
BR,
makes
not
sense.
BR2, and the number for bromine is wrong. It says 2, not 3. So there's 2 things wrong with this one. So the only one here that is accurate and true is letter B. Good job. I'm going to shut the air. Are you cold? You guys cold? I'm a little cozy. I could even put my shirt on or answer or how about this one? How many mole ratios can be written for this? How many different combinations that are unique would be in this one here? Right? 6. Okay? You got these 2. Give me 2. This one, and then I have this one, and then I have this one. 6 combinations. Okay. Section 2. Here we go. Now, today's lesson really deals with starting to solve stoichiometric problems. I'm going to hand this out to you and teach you about it today. I call this the flow chart because it really describes all the different ways that we could solve a stoichiometry problem. Don't panic, okay? We'll take plenty of time to develop this more on Tuesday, Wednesday, and Thursday next week. So I'm going to get you started today and give you a couple problems over the weekend to start practicing on. Yes? Why not? You're unselfish. You gave them all away. Okay, today, what we just talked about was called a mole ratio. In the very center here, where you see number 2, number 3, you'll see the word mole ratio. Okay, and the simplest kind of problem, I'll do one on the board for you in a few minutes here, is if I have X number of moles of something, how many moles will I produce? It's pretty simple. You just take your starting number and multiply by your mole ratio. So if I'm using this equation here, N2 plus O2 produces nitrogen dioxide. Let's put 2 here. Okay, and I said I have 10 moles of nitrogen. How much NO2 will I produce in moles? All I need to do is put a mole ratio here. 2 moles of NO2 per 1 mole of N2. My L, I couldn't figure out if the L was part of the L or an N2. Okay, so then here's my mole ratio. So this times this, everybody? 20. So this would tell me 20 moles of NO2 are produced every time I use 10 moles. So it's just a 2-to-1 ratio. So the middle here is a very simple concept. That's where your mole ratio goes. You'll see on the left, and you're going to ignore the green ones at the bottom here for now because that will be in a future chapter where we deal with gases. We're going to be dealing with these sections right here. A certain problem that we will do will either start with grams or moles or molecules, atoms, formula units. It will end with, it will say, calculate how many either grams, you'll end up here, or moles, you'll end up here, or molecules, formula units, or atoms over here. So it's just a little flow chart to say what steps do I need to do in order to get my answer. Now, I'm going to give you 2 slides that have a lot of words on them. Basically, it's going to tell you how this works. You can write them down if you want. You can summarize them in short term if you want. I'm going to go through them with you just because some people like steps. But look at the picture as you look at these steps. Number 1, balance your chemical reaction. Always, always. Can't do anything on these problems until it's balanced. Double check, even if I give you one. Even if the book says it's balanced. Even if I give you a handout next week with extra problems on it and it says, solve the problem for the following balanced equation. Double check it. Always, always, because people make mistakes. Number 2, determine where to start. Okay? Look at the number they give you. Is it in moles? Is it in grams? Or is it in formula units? Or atoms or molecules? My starting point is either over here, number 1, or your starting point could be number 2 in moles. Number 1 is going to be in grams, it tells you right there. Number 2 is molecules, formula units, atoms. Number 2 over here is in moles. So where am I starting? If it's mass, I'm going to start up here, and the first step will be to change it into moles. And we know how to do that already, molar mass. See the word right there between 1 and 2? Molar mass. If it's in molecules, atoms, formula units, I'm not going to use molar mass. I'm going to use Avogadro's number, and that's what it says right here. Cool. Okay. You can use this sheet for the next 2 weeks. I will decide eventually in the next 2 weeks whether you can use it on the test or not. Usually I do let you use it on the test. Okay? But by then we've done so many problems, you probably won't need it. But Avogadro's number is over here, 6.02 times 10 to the 23rd. You ever see it? Right between this 1 and 2, and this one's molar mass. So if you start here, you can use Avogadro. If you start with grams, you can use molar mass. Step 2 continues, okay? If the amount is given in moles, then we're starting at step number 2 right here. We don't need to convert grams to moles if it says you have, like this one, you have 10 moles of nitrogen. Well, I don't need to change grams into moles. I don't need to change molecules into moles. It's already in moles. I'm starting right here at step 2. Okay, number 3. Then we're going to use the mole ratio. Losing my voice. Here we go. So we just learned about the mole ratio. Now you're right in the middle between 2 and 3. You see the word, mole ratio. I'm looking at my chemical reaction saying, what is the coefficient of this that I'm trying to get to, divided by the coefficient of what I'm given. Okay? And when we do a problem like this in a minute, you'll see the units tell you exactly what to use. You don't need to memorize what I'm given, goes in the denominator, and what I'm looking for goes in the numerator. You can if you want, but that's where the mole ratio goes, right smack in the middle here. Okay, step number 4. If needed, there's 3 options. If the answer is asking for an answer in moles, like I did right here, I'm done. I'm going to stop right here at number 3, where it says moles. If the question asks you to change how many grams of NO2 are produced, I got one more step, molar mass. If the answer says how many formula units, or in this case molecules of nitrogen dioxide are produced, I got one more step, Avogadro's number. Okay, so these 3 points right here are stop here, continue on to number 4 here, or continue on to number 4 here. So these words here just explain what this says. The picture, I think, is pretty self-explanatory. Good? Keep this with you. Don't lose it. If you do, I got extras. So we're going to skip over this because I like doing my own problems here. So let us do one of these problems. I'm not going to do that one. Oh, I know what I did. I'm going to do number 11 from your homework for the weekend. Yay! Okay? So, page 275, number 11. 275, that doesn't sound like the right page. We're in the page 400s in my other class. Let's see. Chapter 11, page 2, 375. Maybe it's 375. Yeah, 375. There we go. Okay, 375 says this. Methane. Again. Okay, you better know what methane is, okay? I'm not going to tell you the formula every time, but you should know methane, CH4. And in this case, it's not reacting with oxygen, it's reacting with sulfur. S8. Sulfur is one of those weird allotrope things, okay? So it has 8 atoms combined into this structure that is still pure sulfur. So this tells me the formula. I don't need to guess at it. It produces carbon disulfide. And guess what? In the question, it doesn't even tell you what the other product is. Suppose you try to balance this right now. What's the problem you're going to run into? There's no hydrogens on the right-hand side, right? So if you try and balance this, I go, so they're either going to give you the reaction, or in some rare cases, like we did with the bell work today, you'll need to know what the reactants are. If it's a single displacement reaction, you should be able to figure out what the product is. If it's a double displacement reaction, you should be able to figure out what the product is. And this one, I wouldn't expect you to figure out what the product is. So this is the stinky stuff that is rotten egg smell, hydrogen sulfide, that they put in natural gas, by the way, to give it a smell. And we need to balance it. Now, CHS. 1, 4, 8. 1, 2, 1, 2, 3. 1, 2, 3, that's cool. If you figure out the answer to this, let me know. It took us a few minutes in the last period 1 and 2. This is not a simple one. You struggled with it. Raise your hand if you're the first one you think you got it. Where did my stupid schedule go? I got it yet? There's my schedule. Yay, grade 6. Good, we're doing well on time. I do it on the board, but I embarrassed myself twice today already on this problem because I got stuck with it. In second period, Victoria Foster figured it out first shot, pretty much. So, yes, Katie?
Is it 2124?
Doesn't sound right.
Johnny.
Let's see. Let's see if it works. 2, 1, 2, 4. That's 8 hydrogens. That's 8 hydrogens. That's 2 carbons. That's 2 carbons. That's 8 sulfurs. That's 4. Oh, that does work. Really? Is that the right answer? Doesn't sound familiar, but we'll put it in there. Okay. 2, 1, 2, 4. Sorry to doubt you, Caden. Okay. Excellent job. This one is tricky. If you, I went through it and I started spinning circles where you change this, you change this, you change this, and that changes your first thing, and then you change that, and then you change that, and then you change that, and that changes the first thing. Okay? Anybody stuck in that loop right now? Yeah, it's crazy. Okay, so this one you might just need to do some trial and error. Okay, so 2 carbons. Let's just make sure it works. This is what I did. 8 hydrogens and 8 sulfurs. 2 carbons. 4 plus 4, so that works out. And then 4 times 2 is 8. 2, 8, 8, 2, 8, 8. Step number 1, done. And that's the first question. Balance the chemical reaction. Step B, calculate the moles of CS2 produced. Okay, so we're looking for this in moles. When 1.5 moles of S8 are reacted. So the first thing I'm going to write down is what I'm given. 1.5 moles S8. I like to put it over 1, so I'm not tempted to divide it by something. My mole ratio here is what's going to be multiplied by. So it's a 2 to 1 ratio. And I'm literally going to write 2 moles CS2 per 1 mole S8. And then I'm done. Yeah. I'll just drop it on my desk for you. Can anybody do that math in your head? 2 times 1.5? 3. Good. So the answer is 3 moles. CS2. Ta-da. Cancel out your units, make sure it's right. Make sure you didn't flip this upside down. So here's your double check. Again, when you cancel out your units, it will tell you if your mole ratio is upside down or not. Okay, the coefficient has to go with substance. Remember about a week ago I said, make sure you get in the habit of start writing the substance that goes with your numerator and denominator. That's why, because now you're going to see a bunch of things in here. And this is moles of S8 that cancels out with moles of S8. If this was upside down, it would be 1 mole of S8 over 2 moles of CS2. 2 moles of CS2 is not the same as 1 mole of S8. So your units have to cancel out. Whatever's left over for units here has to be in your answer. Ta-da! Who thinks it can do that? Good. Okay, that's the simplest ones where we're going from step 2 to step 3. 1-step process. Okay, letter C says how many moles of H2S? Question mark over here, H2S. How many moles of H2S are produced? Now it doesn't tell me anything else, so I'm going to assume we start with the same amount. How many moles of H2S are produced if I start with the same amount of sulfur? But now my mole ratio is different. The mole ratio for H2S is 4 to 1. And the math here is almost as hard. 4 times 1.5? 6. Okay, good. And so my units cancel out here. Moles of sulfur, moles of sulfur. The answer is 6 moles of H2S. Questions on these? Okay. Let's do one of the longer ones. Okay, so this is the shortest kind, has 1 step. I'm going to show you one example now of the longest ones that have 3 steps. So if I start over here with grams, and I end up over here with grams, it's 3 steps instead of 1 step. Let's do one. For the following reaction that we had in bell work today, okay, CH4, O2, CO2, H2O. Coefficients were 2 for the water and 2 for O2. Balanced chemical reaction. Okay, first question is, if we start with 100 grams of methane, so sometimes I just write it underneath this here, just so I know that's right. And then I'll put a question mark underneath what I'm looking for. So the question says, if I start with 100 grams of CH4, how much water will be produced in grams? So I always kind of label my chemical reaction as this. I make sure it's balanced. I put my starting amount with units, is it moles or grams, and I put what I'm looking for, moles or grams. I would encourage you to do the same thing, just get in the habit. It's just a nice, easy way of keeping track. What am I starting with? What am I looking for? Okay, we're going to follow this little graph right here. Step number 1, change mass into moles. So I'm going to write 100 grams CH4. Whoops, CH3, where did that come from? CH4, and I need to change that into moles. So the molar mass of carbon and 4 hydrogens is 16. 12 plus 1 plus 1 plus 1 plus 1. 16 grams of CH4 in 1 mole CH4. Okay? As we go across here, you'll see each time my units have to cancel out. Now I have the number of moles of CH4. My next step is to use a mole ratio to figure out how many moles of water are produced for each mole of CH4 that reacts. What's the ratio? 2 to 1. Right? So my next step, I'm going to put a mole ratio here. 2 moles H2O. Coefficient is all I'm using here for each 1 mole of CH4 that reacts. So this is my mole ratio. This one is a molar mass of what I'm starting with. And then the third step, since this is asking me for grams, I have one more step. I'm going to go right here from number 3 up to number 4. I need a molar mass to change moles of water into grams of water. What's the molar mass of H2O? 18. So my last conversion factor here is going to be times 18 grams of H2O per 1 mole of H2O. And this one is going to be my molar mass of what I'm trying to get. Molar mass of what I'm trying to get to. Now, check your units, because my units will tell me if I flip something upside down by accident. Grams of CH4, grams of CH4, check. Moles of CH4, moles of CH4, check. Moles of H2O, moles of H2O, check. Okay, and if all those things cross out, then you grab your calculator, take 100 times 2 times 18 and divide by 16. 225? Do we trust them? 225 grams of H2O. Okay. So this is as long as they get. It's a 3-step problem. Your setup should look just like mine. Please don't try and find a better way of doing it. There is no better way of doing it than using the units analysis method, dimensional analysis method. Okay. When I look at your work on our quiz next week, I'm going to be looking here. Do they have the right numbers in the right place? And then you get punch it in your calculator right. Okay? Now, so we have the short ones, 1 step. We have the long ones, 3 steps. And obviously I can have the 2-step ones. If I give you grams and ask you how many moles, I would stop right here. If I gave you moles and asked you grams, I would not have this. I would start here. If I gave you grams and asked you molecules, then instead of this here, I would have Avogadro's number. Okay? And if I started with a number of atoms or molecules over here and asked you moles, then I'd have Avogadro's number over here. So just, the map shows you where to go. Okay? Where am I starting? Grams, molecules, or moles. Where do I need to finish? Grams, molecules, or moles. The middle step is always going to be mole ratio, okay, between number 2 and number 3 on your map. Questions? You have 4 or 5 of these to do over the weekend. do your best. I know it's brand new, okay? This video will be posted tonight or tomorrow if you want to watch me do this problem again. I got more time in with you guys than I do with period 1 and 2. So I'm going to send out a reminder and tell them it would be a good idea for them to watch this if they wanted to see one of these problems worked out. Period 1, I didn't get to this. Period 2, I did, but I think I did the best job with you guys.
Yeah.
Okay?